Okay, well, welcome to physics. Today we'll be talking about units. The main objective of the lesson is to understand what are units, what are vectors and scalars quantities, and how these units can affect our daily lives. Okay, units, also known as physical quantities. All physical quantities have a numerical magnitude and a unit. In this case, we can see the magnitude is 131.8, and the unit that is given in here is pounds, as shown as in the small circle here. You may also see this in other places. Volume of water, 100 milliliters. 100 is the numerical magnitude and milliliters is the unit. Okay, assumptions of units. Now, we all know about units, we know numbers. Now, if you were given a choice of 10 meters, 10 meters, something in centimeters, and something in kilometers, what would your assumption be to each one of these? We obviously know that the length of the house will surely be in meters, as in the normal size of a house is in meters. No house is greater than meter, rarely occurring here. Length of paper, standardized A4 paper is measured as in centimeter. The distance between Jakarta and Banten, which is like approximately here to the airport, from our school to the airport, is in kilometers. That's how you measure distance and how we conclude which units to use as a if we already know the magnitude but we do not know the unit. This is the best way to figure it out, especially when the number is pretty small. We can pretty much be sure on how the sizes are. But it's not too rare that some length of paper, for example, could be used as zero point 0.8 meters, but then it's zero point 0.8. It cannot obviously be zero point 0.8 centimeter. That will be too small. Okay, the SI unit, also known as Système International, founded in French, and that's why it sounds French. From what we know is that its length as a base quantity, uh, meters, and base symbol is meters, the small m. Now, some of these may are repeated. That's why you need to focus on which capitalization and how each words, each letter and each base unit pairs up. Meters is small m, second is s, and so on. Now, these are called base quantity for a reason because base quantity is a basis for something that we're gonna discuss further on. Okay, we're going to the next slide. How do we get derived units? This is what I was talking about. Derived units comes from base units. As we know, speed's formula is distance over time. Now, what is the unit of distance? It's in meters, as from the table in the previous slides. Here, length is in meters and time is in seconds. So distance is meters and time is in seconds. So we're just gonna replace the distance and the time in the equation with their symbol. Thus, the formula, the symbol for speed, the unit for speed is meter per second, or in AS level, we'll use meter second power negative 1 because a dash means something else in AS level. Okay, homogeneous equation. Equations that have the same base units after all the calculations are done are homogeneous or balanced. I don't think it's called base units. Wait, unless base units, it's actually, yeah, it's not base units. Actually, should be probably derived units since both mechanical energy (ME), PE potential energy, and kinetic energy are actually calculated. Now we can see that ME equals to PE plus KE, and all of them are joules. That's how we know it's a homogeneous equation. Is if all the final, if those things equal and basically different units through different calculations ended up having the same base unit or the same unit in this case, will have the same unit. They are called homogeneous. There's actually some more, but I can't find prefixes. Yay! These are the determinant of sizes. Sometimes it could be here actually. You can actually see that meter, we go kilometer. That's why that's why 1 kilometer is 10,000 meters. It's from here. And sometimes it may be confusing. So here, it's the, what do you call? Goat bridge, or, okay. It's the great merciful king hates dragons because dragons continually murder men. So you memorize tera, giga, mega, kilo, hecto, deca, the base, deci, centi, milli, micro. And there's actually some more, but it's not here. These other ones are called, wait, let me go type in. There's more, there's nano, and there's pico, which are, if I'm not mistaken, it's 10 to the power of -9, and pico is 10 to the power of -12. Okay, moving on. Okay, error. What the heck happened here? Oh, wait, never mind, sorry. Okay, here. Types of error. There is 2 types of error, systematic and random error. Systematic error is a zero error or inaccurately calibrated instruments. Systematic error, actually, like based on its name itself, systematic, it's from something device that you use that involves the system that even us students, we don't understand. We just use the system given. And that's why it's zero error. It's usually the vernier caliper miscalibrated and the micrometer screw gauge starting in a different position. That is what we call systematic error. Random error, in other case, is parallax error, carelessness in making, reading, or recording, or wrong techniques. These are random errors because we cause them. It's random because we sometimes don't understand, and that's why it's called random. Results of error. Experiments fails. Data is not reliable. For example, these are the results of probably random error. Because if we know that the calculation says it's like you use 100 milliliters of something, of a liquid, but then in an experiment you miscalibrated and it's 105, for example. That's what you call a result of an error. It's like the data is not reliable for some random reason. Okay, precision versus accuracy. These data are taken from the Merriam-Webster dictionary. Definition of precision, let's just read it together. The quality or state of being precise, exactness, the degree of refinement which an operation is performed or measurement stated. So precision is when you actually continually getting the same results. While accuracy, the freedom from mistake or error. So basically you are on target. You are on target. The exact one is you are always getting there. You are getting the right spot. Now, here's a diagram that will show you what I mean by the definition. So high accuracy and high precision. It means that you have good aim, and also you continuously hit in the right spots. Now, low accuracy and high precision is that you hit the wrong place, but you hit a lot of times. High accuracy and low precision, you're basically going there, but you're not always hitting the same spot. Because like precision, you're precise, you're always going there for the same part. Well, accuracy means you go in the right place. Now, low accuracy and low precision, wait. Yeah, low accuracy and low precision is that you're just randomly, you're not even aiming. For example, like a random gunfire, a gunman in school, just like randomly shooting guns, hoping to aim for people, and that's like probably how they do it. Maybe I have no idea. Okay, uncertainty. How do you measure uncertainty? Okay, now this is more of a simple one because we're doing additions, and I don't think I am going to explain how to. Yeah, I'm not going to explain how to do multiplications, but multiplications will be different for the percentage uncertainty. Now, for normal uncertainty, it's you're just simply going to add the units together, add the normal things and add the uncertainty together. So in this case, it's 18 plus 19, which is 37 centimeters, plus minus 0.4 plus 0.01, which is 0.41. Now, for percentage uncertainty, it's the exact same. You add the front and you add the back and percentage. But sometimes you actually want to convert it back into the number percent uncertainty. So we're going to use 100. In this case, we're going to 5 over 100 times 150 equals to 7.2. I think it's actually, yeah, it's probably 7.2 exact to the dot. I'm mistaken. Yeah, it's 7. Oh, wow. Okay. I probably made a mistake here. It's supposed to be 7.5. So don't bother on what I wrote. Fortunately, this is wrong here. This is supposed to be 5. No idea why I wrote 2 there. Okay, now what I said, it's gonna be different when the symbol here turns into a multiplication. It's gonna be harder because then you must make the percentage into actual numbers first. The percentage over the value it's connected to. But we're not gonna learn it in this section, in this session. So scalars and vectors. Okay, now these are the basic explanation of scalars and vectors. Scalars have magnitudes, but it does not have directions. Vectors have magnitudes, but also it has directions. So the green ones are similarities and the red ones are differences. For example, distance and displacement. Distance is a scalar because a distance between town A and town B is measured as 50 meters, while displacement, the distance between town A to town B is measured as 50 meters to the, 50 kilometers in the northwest direction. It has a direction to it. It has it has a magnitude and a direction to it. Okay. For example, the example that I explained, distance and displacement now. Speed and velocity is basically, they're using the same calculation. It's over time, but they're just using the different version of it, as in this speed uses distance and the velocity uses displacement. Or else you'll get the same thing. Now, vectors. This one is pretty confusing. So pretty much for vectors, you actually have to measure a vector. Okay. So the vector is actually a displacement. I believe, yeah, vector is a displacement now. We know that A is in this area, and it has this thing and this thing. So a vector is like the shortest point, I believe, actually. So then to do this one, it's simply by Pythagoras. Okay. This is some of examples of the questions that may appear as in scalars and vectors. Now we know that A is this and B is this. A plus B will go from, we're gonna have A and then we're gonna add the B, which is going down. So eventually you get this. For A minus B, you're going to have A going first, and you're gonna do B adding onto the A, but you're gonna make the arrow go the opposite direction. To A plus B, we're gonna actually finish this one here. To A plus B, so we're gonna go down. The vector here is we're going to go 3 down and 2 to the right, which just means it's going 1, 2, 3, and it's going here. So this is 3, this is 2. So we'll have it here. Yay. Okay, that's it. Thank you for this class. I'll see you next time when we're having another class.